bit about React. And today, as we were saying last week, yes, today, as last time we were just discussing, we will be just using into how can I say it, for our project, we saw recursion, right? And it's supposed that today we have to see searching. As you can see, we have just searching and uh, uh, slide linked list. That means like, oh, we are at least on the basic of data structure and algorithms at the very end. But because we are quite fast going with these topics, and you are basically with this practice exercise, suppose here very far, then today, as we discussed it, we will just see it, what is sorting. As I told you last time, we will just be checking three types of sorting. One is bubble sort, uh, bubble sort. The second one will be, in this case, merge sort. And the last one, it will be something that I see someone would like it, and it's called counting sort. Exist other ones that is, in this case, quick sort, radius sort, radius sort. That they are very used in specific cases. A quick sort and merge sort, let me put it here, they are like a brothers. Why I decided to go with merge sort is because merge sort is what JavaScript use under the hood, the majority. Just more memory, but I think it's efficient when there are not too many projects. Quicksort tends to be less memory efficient, but quite slow when you have more data. And Reddit sort is something like not that useful for what we needed. But it's nice if you later can just check this one. If when we go, for example, uh, let me move this. Sorting, sorting algorithm. Why is this sorting? Sorting algorithms. If we go to the different sorting algorithm, you will just come here and you will find like the most common one: bubble sort, insertion sort, quick sort. Yeah. Bubble sort contains a radical sort, it was with X, and merge sort. These are the most common that you have. This is not in place, and this is in place. The difference between this one and this one is this use more memory, this use quite less memory that you have. Today we will just merge sort, and we will just content sort and bubble sort. That is what we were using. As you can see it, there are more algorithms that we have it. By the way, we will just see it a visualization of sorting algorithms. Algorithms. And and here are the different algorithms that we can say. For example, you will have this one, bubble sort. I will share it with you, if you don't mind. This one, you can see the different algorithm that existed. We can see it. And I think, I don't, bubble sort. This will be margin sort. This will be counting sort, and that is like the different algorithm. Then you will see selection sort, insert sort. This is quick sort, random sort, I don't know without erratic sort. Yeah, we will just see it. One of the most common algorithms that we will have it. And what is the idea? Okay, first of all, before the boo start killing me and telling me, Mario, you just sort and that's it. Don't even destroy my brain with a lot of information that is completely useful because I will never apply it. The idea is mostly to know how they work and the different approach that the system is using in order to just train our brain or train our thinking um, approach, nothing more. Yes, absolutely. Everything. This one we will make it. Okay, it's absolutely sort and you have the algorithm. For example, you have everything, and you say array dot sort over. Doesn't really matter in this case. Everything will be checking. Everything will be solved, and you don't have to be thinking about anything. It's quite a good algorithm, and you don't need to be thinking about it. Yeah. But the idea is that we have more ways, or at least to understand how the algorithms work, and then you can just apply it into the real life, right? That is the main idea. Um, Quicksort is one of the easiest algorithm to apply. Is basically under one idea that you have in this case, you are always looking for the biggest number, for the biggest number. For example, you have this array and you start thinking like this. Okay, this one is bigger than this one. I will just add here a copy of this array just to go over here. The idea of bubble sort is just taking the biggest number and putting it at the end. Taking the biggest number and putting it in the air. That is why it's called bubble, because you have a bubble and this bubble is just pushing the numbers to the outside bubble. That in this case, go to the next element. And it's just like this. Is this element bigger than this element? Yes. Then change places. The 25 go here and the 34 go there. Now you change the places, say 35 and 64. Is 35 bigger than 64? No, then we pass here 64, 64, 64. Then we say 64 is bigger than 12. Yes, then we swap places and we just put the 64, the 64. Then we say 64 is bigger than 22. Yeah. And then in this case, we pass the 22 goes here, 22 and 64. 64. Then 64 in 1, yes. So 1 is smaller and 64 go here. 64 and 88? No, then we pass, in this case, 64 stay there, 88 go here. 88 and 11? Okay, 11 go here, and then go, in this case, 64. 64 and 90, and then go, in this case, 90. What happened here? 90 is the biggest. And you continue repeating this. But now you know that the 90 is already the biggest, then I don't need to know to go there. Then I will go till this moment of my array. I go 25, 34, they stay 35 and 12. Ah, okay. Then I go 25 and here is saying 34 and 12. I swap it 12 and 34, 34 and 22. Then 22 and 34. 34 and 1. I move the 1 and I pass the 34. 34 and 64. 64 stay over there. Then I see in the other one, I go and say 64 and 11. Let's go 11 here and 64 go over here. I think here I make a mistake. This one, it will be, if I'm not mistaken, no, and it will be 11, 1, 11, 1. And here I have 64. 64 in 1, I put here 1, and I go 64. And 64 in this case in 90, I go with 90, right? Sorry that I am making that inconvenient there. And now 64 is the second biggest number, and 90. These one are in order. Then I just have to sort till here. I don't have to sort the last two because I know that they are already sorted. And you continue here. Just checking. This one is bigger than this one. Put it up. This one is bigger than this one. Put it up. This one is bigger than this one. Put it up. And that is the only thing that we are doing it in bubble sort. You are iterating. You are taking the first number and comparing with the next one. If this one is bigger than this one, swap. If this one is bigger than this one, swap. If this one bigger than this one, swap. This one bigger than this one, swap. And every iteration, the array is getting smaller. Why? Because the last number, in this case, get it already into the bigger, into, in this case, that they are already sorted. And that is basically bubble sort that is doing it. Just comparing and swapping and leaving the biggest number always at the end. When you finish all the iteration, you will have an sorted array. Yes, this will be working only with numbers, or in this case, the majority of letters too, because we can compare it. And yes,
it's swiping from the first index, I mean, from the 0 index with the first index, or is gonna swapping from the 0 to the last one? Always.
No, it will be the 0 with the 1 with the 2, the 2 with the 3,
Okay.
the 3 with the 4, and you are always swapping the next one, the brother here, the next one, the next one. You are just comparing one with another one. I will be showing you here. This one we have bubble sort, and let me just go. Okay, go. Oh, why this? Okay. I had this tab.
Oh, now I
Right?
see on your the website you
Huh?
click the sort
Um,
on bottom left bottom. Oh, from you, yes.
yeah.
Yep, and
Yeah, and that start moving it. Then start looking. It's bigger. Okay, move it. Move it.
then it's gonna be two variables, like a first, the 0 index and the first index.
Exactly. And then you already know that they are, and you are just with the next one. The next, okay. Bigger, bigger. Then that one is already sorted. The other one, okay, bigger, nothing, nothing, bigger, bigger. Then the next one is.
Okay.
And that's basically what is the model doing it. Just taking, okay, I am bigger, go to the right. I am bigger, go to the right. But every time you are just swapping one less.
Mm-hmm.
And there is your, in this case, your array sorted. That is what we have it over there. Questions so far here?
Is it gonna work with the letters if we have a target for the letters, which we go?
Yeah, but thing combining with the letter is like when you have the repeated, let's say like you have something like this. If you have an array and they are like a B and AC, uh, it will make it mathematically, it will work, but it's not normal that we are just using it in this case. For example, if let's go and inspect it here and we go to the console and you say something like AC is bigger than in this case than AB, for example, then they will be give you true because the C is bigger than the B. But for example, if you say D, then it will tell you false in this case. The letters are compared in this case as a numbers because JavaScript transform it into some numeral and see it like, okay, A and A, but if you have AA, then it's true. You have A and X. Let's say like you have Mario is bigger than, for example, a the wood. Yeah. And then this case, yes, why? Because mine started with M and you started with D, then the way that the alphabet is working is going over there. Something that I don't like about this approach is if, for example, if I have here Mario is bigger than Mario, and then is saying that is false. But in this case, if I have something like that, it will be true. It will the the letters, uppercase and lowercase, tend to be different. Then you have to see what is just what you wanted to say, right? Just use a number, but it will be working absolutely the same. These are the equal, but if I say this one, it also will be false. It will be true, and this one will be false. This one will be true. Yeah.
This is how the built-in like function sort is working, right? This
Eh,
that's how it's
mm,
like how to put if you sort, for example, the vowels
uh,
letters like that's how it's like sorted. This
because JavaScript work in a lexical way,
yeah.
that will not work in other language possibly. That is why, because JavaScript understand everything like a text and lexical in the lexical way to do it.
Yeah.
Then basically, a bubble sort is just iterating every element, and compare with a second iteration and swap element. Then what is important here to know is the the swapping, how to swap an element without having any inconvenience, right? First, you need to know, for example, mm, how many elements that you have, or you can just go and just say for, let's call it here I equals 0, we will start it, to the length, sorry, to array, to I less than array, I call it array dot length from I plus plus. This one is just iterating, right? Element by element. I will take that, for example, this element and I am iterating. But we have to iterate it and compare with everything. And when everything is already sorted, we don't have to check the last element. Then we just say from let, I will just call it j equals 0. I, in this case, array dot length dot length, but this one length will be minus I minus this one because I don't have to go till the end. In my first iteration, I go till the end. In my second iteration, I go till minus, in this case, minus one. And by the way, we have to go minus one, right? In order to do it properly. No. It's just I, not minus one. Usually less, yeah.
You
And
need
then,
to J, not to I.
ah,
Array dot length is supposed to be less than J.
yeah, less than J, right? Because we are just going to J, and then in this case would be J plus plus. Thank you so much.
It's like we are skipping the last one every time.
Yeah, because the last one, every time we're in every iteration, if you see it here, the last element is already swapped. It's already in this case, is already sorted. Then I don't need to check it. In the first time, I arrive till the end because this one will be 0. Then the length minus 0. In the E, and for example here, I know that the last element that I have it is already the biggest one. Then I don't need to check it second time. The second time that we go, we arrive till here because, and we take it, that is the second most biggest element. In the third iteration, I arrive till here. The fourth iteration, I arrive here. The fifth, the sixth, the seventh, the eighth, the ninth, and I don't need to check it all the time because the idea of bubble sort is that every iteration we are taking the biggest number to the last position.
Excuse me, Myra, is it the
Yeah.
same? I'm just confused. Is it the same logic with the swapping in line 8 and 9? Are you explaining the same type of sort, or is you are like moved to the another option of sort?
No. It's just in this case just bubble sort.
So like from the beginning of the class, we are discussing about bubble sort, right?
Yeah. That is why I noticed here that I say which one we will just see it, but we are just talking about bubble sort.
Then I'm confused why you are skipping the last one.
Okay, maybe if
You are
we see.
swiping, right? When you are swiping, the last one will be not the last one. It's gonna be the last one.
Okay, let me just go here with bubble sort. And that is what, for example, every time that we are sorting here, we are just swapping, right? We are just swapping the biggest element till the end. We are swapping the biggest element to the end. We're swapping everywhere. Now, at the very end, you have the biggest number. We cannot do it, but it's just the algorithm help it to not to go to the last element because the last element is already the biggest one. Then
But
in the next set,
actually the first element. If
yes, the first.
no, it's wrong since it's not the first element. For example, if the last element gonna be the higher than the first element, that he's not gonna swap it. Okay, I got you the idea. Like, okay, he will find his place.
Exactly. And because he already find his place, then I don't need to move it, right? All is correct. And every iteration, I am just making my array smaller, small. Uh, it's just for efficiency, this one. But basically you can do it. But for example, if you are swapping number, this and this, okay, 20, if you have to swap it, right? You will swap it and you swap it with this. Okay, this and
Question
this.
I have a question. For
Yeah.
example, in the third iteration, let's say you have at the last two, the last two your the indexes. Here the value is like 100 and 110. Let's assume that. And you have the highest number in the middle, like 120. And in that case, if we skip it in the J the last one. How it's gonna work?
You are saying here 120.
The last
Let me
one,
just
like
let me just make it here smaller, and here will be 100, and here will be 110, right?
Yes, but the 120, can you put like in the middle of, I don't know, like
Yes, absolutely. Here it goes well.
it doesn't matter, yes. For example,
Okay.
the 34 will not
Uh-huh.
gonna stay like the last one, right? Like
Okay.
in the beginning. It's gonna be no, he's not gonna stay here, right?
Let me just show. The thing is like you are always showing one after another one. Let's see. The algorithm works like this. First one, we take the first element and we compare it with the second element. This one and this
Swap.
one. Which is bigger?
34. They will swap.
34. They will swap. It will be 25 and 34. Now you go with the second element, that it will be the position 134 and 120, which is bigger? 120.
They will not
Then
swap it, right?
they will not swap it. Then it will be, in this case, 34 and 120. Now, 120 and 64, they
Not
will
gonna.
swap. They're going to swap because 120 is bigger than 64. They're
Yeah,
going to
moving.
swap.
Mm,
Okay, now here you 64, I hate 64 and 120. Now 120 and 64,
and they were gonna scrap all of them.
yeah,
Okay. I got
okay, the
sorry.
64.
But we are iterating the null number one, no? The first index.
The first index at the first time, this one. Then we will iterate the index 1. Then in this case, both from the 0, the index 1. We are just iterating in the next operation. Basically here, this one I is just helping me. This is just helping me just to see how many iterations I have. The first iteration is the last number. The second iteration is the second number. The third iteration is the third number, and so on, so on. But basically, this one is swapping. This second for loop is just telling me, okay, you already iterated one, don't go to the end, don't go to the end, don't go to the end, because I am just usually here. Let me just tell you here. For example, here we just check it, right? This one, and we just say if array in the position J, in the position J, is bigger than array in the position J plus 1,
Yes.
plus 1, right? That is, in this case, the next element that you have it. If that is true, we swap. Here we swap. We swap the element. That is basically what we're doing. And you know, we don't have to go to the last element. Why? Because here we are going to the last element that we have it. Then we need to write till here in order to swap the last one. Yeah, that is why we needed this -1 over there. And this I is just telling me how many elements I have at the end. Okay, in the first operation, I have to go to the end. In the second operation, I will be -1, then I arrive still here, because in the first iteration, I took the biggest number at the end. Then I need to find the second biggest number, then the third, and so on. Is making sense so far?
Yeah.
Maksat?
I'm just kind of confused the part that, for example, when they are not swapping, and then when we go to the next one, I got you. Now I got you. Yes.
Okay.
Okay.
Okay. And Sultan, begin my making sense what I am just doing right now?
Sense.
Okay. Okay. Then here we just swap the numbers. Remember, for swapping, who remember what we have to do? What is the problem that we have with swapping and what we have to do? We are swapping the two numbers. For example, I want to add where
temporary the
exactly.
one array.
Then in this case, I put into temporarily wherever I can just say array j plus 1, right? That is what I have it. Then I can say array j plus array j plus 1.
Equals to array j.
Exactly. Do array j
And
array
array j equals to 10, right?
exactly. Array j equals to 10. And this is basically bubble sort that you are seeing here. This the important part is the swapping. And let's see, in this case, what is doing it? Let's just say it. And we run on the finance because I didn't return anything. Or return, in this case, the array. Okay, empty item we are having over here. Because here is nothing, and this is not problem of the algorithm. This is the problem of Mario. And then here you have your array 12, 22, 25, 34, 64, 100, 110, and 120. Okay, in this case, we don't need to add it anything. And we can see here, for example, I can just say it console.log. And we can just go to the array. If you see it, the first time, it's putting the 120, 110, 100, then the 64, then the 22, then it's just swapping the elements that we are having. Yes. And you can just even check it here, which are the elements that we are swapping. The algorithm tends to be very simple, but
Mario,
yes.
why we like assign let temp array j plus 1?
Array j plus because we want to see, right now we are here, we want to see the next one, the next element, in order to compare. We are, for example, you start from the 0 and you want to see the next one. And j, in this case, is just an array, just an iterator that is starting from 0, and you see the next one. Then you go to the position 1, you compare it with the position 2, the position 2 with the 3, the position 3 with the 4, and that is why we are taking all the time our next one. And here are all the comparison that you are seeing, 34 and 25, move it. And then you have 120 and 64, you move it, and so on and so on.
Thank you.
You're welcome. And if you want to see all the comparison that existed here, I can just show you. And this is the reality of this algorithm. Look, all these iteration were 34 and 25, 34 into 120, 120 and 64, and all of these iterations were just created.
Mario, in the
Is time complexity 1 O(n) square, right?
Yes.
Double, like nested loop.
Sultan?
Mario, in the first looping array dot length minus I minus 1, how much it will be? 7 or 6? I didn't get that point.
Okay, not a problem. In the first one, the array right now is 2, 4, 6, is 8, right?
Yeah,
It's 8.
minus I.
That is 0.
No, but in the first looping I plus plus, Why it's 0?
No. Ah, it's very interesting thing. But the thing is like what is happening with this plus plus is word like this. Look, first is 0, then is the
Yeah.
comparison, then is what is happening here, and then go plus plus.
Ah, okay.
Yeah.
Okay.
This one, then compare. If the comparison is okay, work what is inside. When it's finished, what is inside, plus plus, then iteration, then here, then plus plus, then check it, and then this one. It's a little bit confusing, but basically, if this is correct, we'll do this, and then we'll go up after finishing here. Makes sense what your question, because okay, it was already plus plus, then this is 1. No, it will run everything and then will be 1.
Mario, can you explain one more time? J like less than array minus y and I and what minus 1, this part.
Oh yeah, absolutely. Every time that we are having this, and the first time here we are having j plus 1. That means like we are always comparing with the next number. We are always comparing with the next number. Then if I am here with, if I don't remove this minus 1, if for example this one will be 8 and 0, let's say it 8 and 0, and I don't have this one, it will arrive array j will be 110, is less than array j plus 1, but I don't have anything extra here, then it will be in this case it will give me a undefined at the very end. It will not be that problematic, but if we see it here, I will just console.log. I will just show you array j plus 1. Just over here, just to show you. It will be in this case. Oh, I don't even understand why it's not arriving, but the idea is that, okay. It's because it's minus j, they will be so. Here you have it, the undefined that I was telling you. It's just to avoid that undefined over there in the first iteration. Then at the very end, it's not a big thing, but maybe it can give you the problem. And I don't want to go to this undefined. Right now it's not yelling, but it just is a risk. That is why I just remove 1. That is this plus 1 to go to the next one. If I don't have that one, I clean it, I add it, I run it, and I don't have this undefined. I never have this overflow of going outside of my array.
Mario, sorry.
No, good.
Can we start like second loop from j from 1, j not 0 but 1? Second loop.
No, because I need to know what is in the first element. I always need to know, because the idea is like the bubble sort is always taking the first element and just swapping. Because imagine that I have something like 54 here, and I don't have the smallest element at the beginning. I don't know, maybe the smallest element is this one. And if I am skipping the first element, then in my second iteration, okay, you can do it, but it will be different. You will have to change your logic. You will be not looking for the biggest number, and then you will be looking for the smallest number. It's possible, but just make it more complicated. I think, because we have to start it from the end and start going backwards. I don't even think like how is it going to work, big in mind. I'm sorry.
Okay.
Yeah, not that idea. Any other question with this? Then this is bubble sort, basically. There we have. If you can post it into the Slack channel, it will be nice because I think I don't have access in this computer to that one. Then, if we don't have any question, we will go with merge sort. And at the very end, we will leave a counting sort just because I think counting sort is just a funny algorithm that I like it, but it's not that useful that we can say it. Okay. I will need this our array. I will need our array. The time complexity on bubble sort is, in this case, big O n to square. Is the worst algorithm that we can create. That merge sort, in the other case, it's quite an effective algorithm, but we have one. It's using two approaches. One is divide and conquer, and the other one that is basically recursion. Then merge sort, what it does is divide every single element into our array. It divide every single element into an array. Then start comparing the left and the right and swapping the element. After swapping the elements, we will supposed to have an algorithm. Let's go and see it here because it's quite complicated to see it. And this is merge sort. The first thing, we'll start divided in all the arrays into the half. First, the first part of the array will be to the half. Then those half will be coded into the half till the moment that we have arrays of one element. Those arrays of one element will be, in this case, start merging one by one, adding all the time the smallest element into the right, into the left. And let's go and see it here, what is it going to do. We have the elements and we are dividing every array into the half, into the half, into the half. Then it's starting, in this case, merging and passing it into the left and doing. Now it sorted the first half. Now the second half, 7, 13. Now 7 and 0, and start 7 and 0, 0. Okay, start moving. Yes. Then you have sorted the first part of your array. Then it will repeat the half. As you can see, it is always divided into the half and start sorting every single element. Then put 0 and 6 and 41. It's just doubling. 64, 13, go down, 25, is sorting every element that we have, 0, 6, 4, 6. Now it will take the second element and start swapping 0 and 0, 6, 7, 13, 13, 16, 21, 64, and 7. And we will have, in this case, our array sorted. The idea of merge sort is two. First one, we divide every single element. We divided every single element in the small expression that in this case will be one element in every array. This two. It has two operations. First, we divided every element. Then we compare it left and right. Which one is smaller? Then you swap it. Okay, you put it into a new array, and it's supposed that is, or it's not supposed. It is in this case sorted. I think it would be making more sense when we are just creating it. Let me just go with the information here. Let's go create the function merge sort. It's just taking an array. We will be using, in this case, recursion. We'll be using, in this case, recursion in order to do it. The first element, we just need to get the half of that array. We just need that array, and I will cut it in the half. Then let's just make the half. This half, it will be an array dot length, those lengths that we have it, and we divide it between 2. As always, this can give you the one number, and we just go with math dot floor or seal or whatever you want. I just using floor. Now that you have that one, that everything is in this case in place, that everything is getting, oh, okay, look, I just have the half. Let's create cons left. That in this case, the left will be equal to the array. In this case, we just say splice from 0 till the half. And that is what we have, right? Splice. And then we have cons right will be equals to array dot splice from half. Just like that. And then let's just return, but I will return, in this case, merge. No, I will just return, in this case, left, in this case, what you have it, and I will just return. Here, now I am keeping in the half. What I will be doing it do is recursion. Now I have to split this into the half and this into the half. I am correcting here? No. Half. One question. How do you think I can cut this one into the half? Because this one will be the array, this part. Now I want to cut that one into the half again. How do you think I can do that?
Left half divided by 2 or left divided by 2?
Yes, but here I already divided. Now I want this half again to be divided. How can I do that?
Left length divided by 2.
The same like half, no?
Right there, we can like divide by 2.
Okay, I do that. And now I want that one divided in the half again.
Dividing.
Recursion maybe.
Exactly. And how can I use recursion here?
Left n minus 1. Left.
Let me just say for here console log, and I will just say left and right. Just to see it, what do we have here? I will just say it console log, and I will just say console log. I will just say merge sort, and I will pass this array, right? The array that I have it. I will save it, and I will have it here. Okay, I have in this case.
The second one is empty. Right.
Yeah, but I think because I am using a splice, it's a slice. I'm sorry. Yeah, because I don't have anything. When I remove the half, I already destroyed my array. Yeah, I'm sorry. There you have 2 arrays, 2 half. I want that one
create,
again.
we should create another function.
No.
Left dot length divided by 2. Or is
Then I can just do it 2 times. But I want this one. The idea of merge
Call the
sort.
merge sort inside the merge sort array or function,
Exactly.
and yes.
Exactly. But now I have a problem, and this is the problem with recursion. What is going to happen right now?
They have different inputs. No.
That is the idea. Okay. Let me run. Let me run again.
Why is it gonna divide it by twice?
You have to set base in order to stop the recursion.
Yes, exactly. And the base case in this case will be if array dot length is equal is less or equal than 1, I will just return the array. That's it. And let me just show you what do we have here. I will just save it. And look, here have it. The array divided into 1 element. So you just have.
Undefined.
Don't pay attention to this undefined. The thing is like when you are divided, sometimes there is a number that doesn't exist. This one, if you say like a CL, you will have a different answer here. It's not CL, maths dot sale, right? Then there you have it. Just a different. Don't pay attention to this one right now. But if you see it, we have here our array divided into left and right, 46 and 64. Now, 64, 46 and 64, which is bigger? Then you just put it in the right and you are moving. Then you have 46 here and 64 here. Then you just check it with them. 120 and 64. Then this pair, you are just swapping each other. You are always swapping this element. Now we just need to merge this array. That is something that it will make it just easier. We just want to, we need to create a function that it will be called, in this case, function, that it will call it merge. This function merge is the second part of our algorithm. This function merge will take left and right. Merge and right. And this merge and right will have something called sorted. That it will be what I will have in this array already sorted. What we need to do is take this element, these two array, and start swapping them. Why? While this left and right will be our sub arrays that we have here. And we just say return, merge, and this merge I will pass left and I will pass right. That is what we have it. Here is arriving left and right. And then we will just say while what do we have it here? And this moment is while we have in left some length. I hope I am just length. Okay, a length, or in this case where we have it here in the other one also some right dot length. In merge sort, the idea is in the left side, in the left, we have to put the smallest number in the left side. That is the only thing that you have to do. On the left, go to the smaller one. Then we just say it, if left, in this case, in the position 0 is, in this case, is smaller, this case is smaller, then, okay, we have to get, okay, the biggest number, we are just passing it to the right. Is the less element in the position left, yes? In the position 0, we are always just checking what we have in the position 0. We never do anything. Then we just get it desorted and we push it one element, okay? Because left is smaller than right, then the smaller number, we are always pushing it in the sorted element. Then we just say it, left dot, removing the first element of this one would be shift, right? And we just remove the first element. In the contrary, meaning that the array is the biggest one, we take the small number and we push it into the sorted element. And we just say it, sorted does push, sorted does push, and we just get the right dot, in this case, shift. The only thing that we are doing here is this one. We have two arrays. One array is second, this is what they are arriving. We compare it to what they have in the first position. We compare them what we have in the first position. And what we are arriving in this moment is 46 and 64, which is smaller, 46. Then we add the 46 here and the 64, which is the second number. Then at the very iteration, we will say 46 and 56. That is what we are returning. And this is returning basically into the first part of the array. Then is arriving the second sub-array. But for now, we don't. Then in the second, it will arrive as 120, will be arriving here, then 120. And the idea is like you have 46 and you create again this 46, 64, and 20. 46 is smaller, then go here, 46. Then here go this and this with 66. And the next one go 120. Then array the other 64, and we are just putting 46. You go here. Here we'll have the 64 in the third operation, and you say 46 is smaller. 56 is go here. Then 164. Then you have 64 and 120. I hate the 64. I don't have to use it. Then is entered in the other one, and so on. Then when you already push it everything, we just have to return something. And what we will return? Well, we will return. Here, we will return the sorted. We will return the sorted. If there is something in the left, we will just get what is in the left. And if something on the right, we will also return what is on the right. And just for you to see it, here we have console.log left and right. And here we have console.log merge sort. This is the solution. And if I didn't do a big stupidity, this is what you have. Look, left and right. Left. I am saying this you pass it 64 and 54. First iteration is returning 64 and 51. Then you passes 120 and 64. Then you put in the less one here, the bigger one. Then you pass it 12 and 22 and 100 and 110. Then they sorted these two and they sorted these two elements. Then there were this one that the first 64 and 21 in this one, they were merged and this they were already inserted. And this one, they were already inserted. And at the very end, they are just saying 64 and 12, put 12. Start 64 and 22, get the 22. 64 and 100, get 46. Then we have here 64 and 100, 56. Then just 64 and 100, 64 and 100. 120 and 100, take 100. 120, 110, 110, and get 120. And at the very end, as you can see it, there are absolutely less operation in this case than the and bubble sort. And this is something that is called divide and conquer. You are just passing in this case till the minimum expression every element and then creating a new array, left side the smaller, right side the biggest number. And basically this is merge sort. It's one of the best algorithms that you can find it in this case to do it. It has two parts. The recursion part, where you are dividing the element, every array into a smaller array, and the second part, when you are, in this case, passing these sub-arrays again into a smaller array that you have it. I'm not sure even to ask, do we have question or something is, it looks like a David, Maxat, Sultan, BMI, something. No, right.
I'm
To be honest, I lost everything in the beginning. That's why I decided to not to try more. I just forget it about the recursion. We had only one class, and I guess after that I didn't even the practice. That's why I forget
Yeah.
about the recursion, and now I understand that it's useless to try to understand now.
Okay.
confused in second part, function, merge function.
Okay. Yes, I know that it's just one class that we have it in, and it's very complicated to understand. But aside of that, the only part that, first of all, merge sort is an algorithm that exists. I mean, like I am not what I said. I'm know this one. No, it's just basically a formula that exists. Okay, it's a formula that exists. I don't have anything extra over here. Let me just. If you are not hearing me well, please let me know, because here my connection is saying that I don't have a good connection. Just in case, text me or say me something. Okay. Yeah, I know that recursion. But the idea of recursion is that recursion just is calling the function again, and we have a base case. I will give you this. And it's not that I just want to avoid the problem and say it. What I can do. Okay. And quicksort tends to be even a little bit more complex because here at least we are just using more memory and you can start seeing the elements joining. Quicksort, we cannot even see it. Okay. The idea is you divide every element into smaller pieces. Those smallest pieces, we start joining it one after another one, being with two elements over here. And yes, everything is just using recursion. Okay. Let's do something. Let's try to go over the algorithm itself. And the next class, if you have time, we can just see it again and continue practicing over here. And I will go and disk over counting sort.
Mario,
Yes.
if in an interview, if I apply for the company and in interview, they ask me this question, I would say I don't want to come in your company.
No, look, I
That's
will be
crazy,
very,
like about this questions too
no,
much.
no. I will be very honest. The idea right now, what I am teaching you or I am seeing you is very unlikely that you will have it. Honestly, if you show me one answer like this, you have to sort something and you do like that, it's fine. I mean, it will work. It's very, but what you can say at the end, yes, I know that exists something like a merge sort, that is one algorithm that divides and in this case and merge it, and it has a complexity that n log of n. I think with that is more than enough. At least you can just say that you know that the existence of that algorithm itself is already the knowledge, because I am also sure for me it took me quite a while to understand how this merge sort works. And the main idea is to understand how recursion works. I will show you, we will have a break, and then I will show you another algorithm that is a big O of n, big O of n, that I am sure that you will like it, that is called in this case counting sorts.
Yeah, the first
And
one was pretty good, like pretty understandable. The first one too, like you're just merging the first and the second index and like swapping it. But this one,
yeah,
much just for the sorting is too much.
yeah, I understand that part, but I will show you a new one that maybe it will make it even more sense for you. That is called, in this case, counting sort. We will say it, okay? Counting sort.
And what's time complexity of merge sort?
Is
O just
n,
while we use.
no, is n log of n.
Okay.
If I have to say it, is the half of the time that bubble sort relative. If you see it, basically merge sort for 8 elements, just make it 2, 1, 2, 3, 4, 5, basically 6 operations. It was using 6 operations that it was just doing it, plus it's pretty better than the other one, that the other one is, and we see it here like a big O notation. And we see it here. I will just go here. And you have this one that we have it here. Is this one. Merge sort is here. And bubble sort is here. Let's say, and it is like around the half. Well, a little bit better than the half. And I can just say it here. Merge sort big O complexity. and it will just is log of n to n to pick O. Here we have a table. Quick merge sort is here, and log of n, and basically here is have. And the space complexity is big O n. The quicksort is good because basically it's smaller. We just don't use much memory. Tends to be. And now we will just see something that is called counting sort. I am not sure if appear here. Ah, here it is. NK, NK, NK. Basically is big O n counting sort. It's very nice algorithm. Yeah. Let's take 10-minute break. We don't think much about merge sort for now. See you in 10 minutes, and we continue with that. I will not add. I will not stop the class because I forget. I always forgot to put it back again. See you in 10 minutes, guys. Okay. Let's put this merge sort aside. Let's use something funny that is counting sort. This algorithm has one inconvenience. Does not work with negatives. Okay. In the case you find a problem of sorting and you only have positive, this counting sort may be the best option. Counting sort, we need to do three things I want to know before starting it. How would you find the biggest number in an array, and how you can create an array of size of the size of the biggest number. Generate one array the size of the biggest number. Question. Let's say like you have this array. How can I know the biggest number in an array?
Math max and use separate operator for the array.
Well, okay. Then math spread operator of the array. Okay. And this is completely correct. And here you will have it, cons max number. Okay, cool. Now, how I create an array of size max number?
Didn't get the question.
You have, for example, 100. Let's say the biggest number here is 110. How can I create one array that has 100 zeros, for example? Here, I need an array of the size 110. An array that has 110 elements. When I say size, it's like a have max numbers indexes.
Using the for loop,
You can use a for loop.
and the maximum is just gonna be the max that length, like and just pushing the whatever you want
Here,
for loop.
I will not deny it works. Would you mind to try to Google or to do something how you can create a node? Because there is a way that we can create it. In this case, an array of size X without to creating that for loop. JavaScript already has a way to do it.
Without the for loop, you say?
Without the for loop, I just it would be nice if you in this case try to
Do you remember that the new array?
exactly new array cons, and we say it array array X, exactly. New array. You just say a new array in this case, and we will just say it max number, for example. Max number. We usually added 1 because remember that the arrays start from 0, right? And if max is 120, you will have 120 elements, but the array will start with the index 0. And we can fill it, just say it in this case, fill.
Mhm.
And you can fill it with 0, for example.
Why did you create extra +1?
Because if I don't know, maybe I will need the 0, right? For example, the
You-
element 110,
Uh-huh.
if you create an array of 110 spaces, which is the last index?
109.
Exactly. Then I add this one just to have this index 110.
Okay.
Just for that, because I want to have an array that start from 0 to the biggest number that I have it.
Mhm.
Have we used field? First time I see it.
Just to fill the array in zeros. For example, you have it here. Let's say that I just console.log this array X. And if you see it, it will have a lot of undefined over there. 101 undefined item. If I just say fill, then I will fill that array with zeros. It's just because it's a common operation in JavaScript, then it's just putting zeros in every single index that you have over there.
Useful.
Yeah, I show you something useful. That's cool. That made me happy. Okay. Now, do you remember how we were using this before when we were seeing the data algorithm? We were using one object in order to, I have one A, I put it here, I have one B, I put it here, and see. Do you remember how was that what we were using?
Do you
I feel
talk
like,
about the frequency stuff? This?
yes, the frequency counter. Exactly. Now we will create, in order to sort something, we will use a frequency counter, but in an array. And guess what I'm going to do? What I am going to do, let's say that I have 246. It will be very simple. Now I will iterate every element. I will iterate it, and this one will be my frequency counter. And for example, I just find 46, I will put it in the index 46. For example, let's say like this, then this will be +1. If I find another 46, I will put it in the array like a +1. Then I will have two elements in the position 46. And then I will iterate all these elements that we have here, and guess what? If they are bigger than 0, I will just repeat, I will just have an array. I will just have an array solution. And if I have let's say 3 number 1, I will just push 3 number 1s here. If I have 246 later, then I will just push 246 I will just use in the index. And in this case, I will just make my array completely sorted. What I am going to do, counting sort, create an array of the max element that you have in your index, and the only thing that you are doing is counting using the index as the frequency counter. 46, I look for the index 46 plus 1. The 46 is +1. 120, then it will make it in the index 120. In the 110, it will be here, and I will have it in the index 110, and we'll be just counting those elements that we have to be here. I think, yes,
And we have to, at the end, we have to get the unique ones. So we have to delete the zeros. So we're gonna use the includes and then
no,
to 4x. Get this one.
that could be a solution, but the majority of time what we do it is just if we just create an element that doesn't have anything. For example, I can just create like a sorted element. I can just use the same array, or I create a new array with the information. But let me just code it in order for you to see it. It will be a function counting sort. This counting sort get an array. We get an array. And the first, we get the maximum element. Cons max element will be equals to max.max. And what we have it over here? We just pass it the array. Okay, cool. Now that you have it the maximum, we just create cons my counting array, and we just say new array, and we just say the max element plus 1, and we fill it, right? We fill it with zeros. So over there we don't have any inconvenience, everything is going well. Then we just say, okay, for let I equals 0, I less than array dot length I plus plus. Now I'm going to fill this array, and we just say it. We have to just say it counter. Let's say my array counting in the position, and this is important, in the position array I, right? In the position array I, because here in the position 46 it will be the first one. In the position 46 plus plus. That's it. That is my counting sort. What I am saying, this array has in this case 120 positions. In this 120 position, I just said go to the position array I 46. Go to the position 46 and make it plus 1. Then it will look the 46 and it will be make 1. Then it will be here, it will be 1. Another 46 in the position 46, go and add in this case 1 extra. Then we just have to say it in this case something like a console.log, and I will say my counting array. I will just say content sort, and I will just pass the array. Okay. Oh, okay. Here we are missing 1 comma. Then here you have it. Look, for example, here is saying that let's start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the position 13. Why that is the position 13? The position 13, the index is? What is the index in the position 13?
12.
12. That is this one, right? Then continue 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. I think like that. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 is the index 23, that is in the index 22 is position 23. And then we can assume that this is the 46, this is the 64, and so on, so on, so on, that we are having over there.
It's actually just finding the index and changing to from 0 to 1.
And then the idea of this one, let's say like we have cons, we can just use our array if we wanted, but let's get it a new cons. Sorted array will be equal to something. Now let's iterate this array. How we iterate? For let element of, right? My counting array. Okay. How can for of, can we get the index of for of?
Index of
Can we,
element?
yes, using for of, can I know the index?
No,
Ah, okay. Then this one doesn't work. Then let's go with the simple for loop. For let I equals 0, then in this case, I less than my counting array dot length, plus, in this case, up plus plus, or plus plus.
you're gonna input the indexes. Well, that
Exactly.
to be honest, it's very stupid option.
What works? That is the idea. And the time complexity is very cool. It's one of the most effective algorithms that we have. It. Now you just say like this: if my content array in the position I is bigger than 0, then what? Then you just say you only have to push that element, that index, into the sorted array. But how many times? That is the good thing about how many times that is going to be doing it. Then we can just say it like this: while, and this is just extra stuff that there are many ways that you can say, my counting array in the position I is bigger than 0. And I will just say it like this: sorted array dot push, and I will push in this case I, and I will say my counting array in the position I minus minus. It's just I want this one like, oh, it was 1, then I am pushing it into my sorted array, then I remove it to 0, right? And it will say the console log, and we save it. Let me, I don't want to see it like this. This is the array. Oh, undefined. I never returned anything, right? Return sorted array. Yeah, 12, 22, 46, 46, 56, 64, 100, 110, and 120.
Can you the console.log the my counting array as well? I just want to say that all the numbers is pure.
Ah, yeah, absolutely,
You are
absolutely.
doing like minus minus.
Yeah, console log, my, in this case, my content array. Yeah, absolutely. We can just see it here, and we can see it before here. Just to see it, right? Here you have it with the 1s. Here you have it again with 0s. and there you have it sorted.
But the quantity of my counting array is still 120. Mhm.
Oh, yeah. I am
If you
removing.
numbers, not deleting the indexes. Okay.
No, I am not deleting the indexes. I am just, this is one, I remove it, what is inside. I am not, in this case, deleting the index, because if I delete the index, I lost the position, and if I lost the position, the net element will not know what is the index that we have it over
The
there.
question is while is bigger than 0. If you will not remove minus minus, the iteration will be infinite loop.
Mhm.
Okay. It's like 36 lines of code to only do some sorting, and also you cannot do the negative ones. The useless code for me.
But the good thing is like this is one of the most, for example, one of the most, how to say it?
The effective, like
It's
this.
yes, and it's the fastest algorithm that you can find it, because basically this is a peak over n, and
Even
even
like
if
can we sacrifice without like the time complexity and use just built-in sort function?
yeah, no. You know, this is more about study the algorithm, not to, yeah, because as I said at the beginning, I will just use sort. And why I will even bother to anything. But the idea of this class is not about to learn the
Yeah, I
on-build
understand.
function. Yeah, because at
You
work
can't
I
answer
will
the
use
question.
this one.
Yeah, to be able to answer to interview questions, I understand it. But I don't know who's gonna ask this question.
How much
Uh,
does that start to understand me? Like when I say the useless, it's really useless.
this one is super useless.
Before the mesh one was even worse than this one.
The, this one at least we can understand it, right? The
Yeah,
previous one is like
it's like for the guys, I don't know, it's like how nerd you have to be like to like enjoy this one, you know. Like,
yeah.
I enjoy
oh,
it.
well,
I feel
algorithm is much
ashamed.
faster than yours. Like all this. You have to be, I don't know who.
Look for a life, right?
Are you enjoying with that kind of code? If yes, you choose the right career like this.
No, you know what I like is just it was so smart people who did it the first time. You see it like it's so simple idea, but I think I will never be able to come up with this idea myself. That is what I find incredible about this kind of algorithm. And I sometimes say they was created a long time ago for mathematician, and if if you can see the beauty or the simplicity of using something like an array just to count things in the because this is the real life like using an abacus if you have 3 stones here and 4 stones here and you start creating this complexity that is coming in the future, it's just personally I find it very cool, but yes, maybe I am a little bit nerdish in that case. But I will tell you, uh, it's not about that this is useful or this is just a graphical. It's more about the idea that's come behind. Maybe in the future, you started, okay, you have an inconvenience. There are more ways to solve it, and the sort resolved it you one way, or is doing what it's doing, is sorting. But this kind of algorithm, you can just, how can I say it, reuse it, not this application, but at least the idea of grouping elements together in order to solve a problem. That is they use that I see it like to expand the way that you are thinking. Okay, I can use things to group other things, and that is everything. But if you say, oh, you will never have just numbers to do it like that, yeah, that is true too. I mean, I will never tell you are wrong. You say, why I have to mortify myself if I have sword. Speaking it directly, you are right, but it's just like that. Okay, these are the three algorithms that I prepare for you. And there are other ones that, as I said before, if you wanted, you can get into Quicksort.
So this one is like
Quicksort.
boss.
Huh?
It's like kind of the quick sort is kind of the boss of the sorts.
No, is merge sort. Is merge sort, but without using. If a merge sort, I am using extra memory. In Quicksort, you are basically not using memory. You are just using one point in order to do it, and that is why it's a little bit more abstract in the way that is working. Being honest, the best one that you can have it is sort. I mean, that is true. This is extremely adapted with what we needed. But if I am not mistaken, what algo use sort function in JavaScript? I think it's using merge sort. If I not the first is a player, right? Could be which sort function does sort?
It's good
Ja-
everywhere. Just use sort.
yeah. So
Of
you
course,
said merge sort
sort
in
keeps-
JavaScript.
Mm.
Uh-huh.
Like that kind of function includes all the options.
Exactly. It is just looking in this case the one because what you are just doing sort, right? You are using sort. But if I'm not mistaken, inside when you are calling that sort, what you are using is merge sort. That is what I said. That logic that we did it before is what is inside this sort. But I am not sure if JavaScript what algo use merge sort in JavaScript is you said merge sort or not? Okay.
That kind of questions you need to ask from ChatGPT.
Yeah, it's better, right? Okay. Okay, I will just. I think I have chat. Yeah, of course, I use this thing all the time.
So I thought you ignored the ChatGPT since you ignored the sort built-in function.
No,
Okay.
Yes, the merge sort can be implemented in JavaScript. It's often used to do the efficient.
yeah, I should. Okay, okay. Let me know. Let me just see. Okay, what algo
Algo or else?
yeah, algo use JavaScript to sort under the hood. Okay. Better typical user call team sort use it. It's an hybrid derivative. Look, merge sort and insertion sort. Yeah, I was thinking that about this one. It's using merge sort, but it's like a more effective even. I don't know this team sort, but I suppose that is team sort is an hybrid algorithm from the merge sort and insert sort together. That is what we have it. And we have here team sort, but we use less memory. If you see a merge sort is quite big, but team sort use n. If you see it here, we have n. Wow, that is cool. merge sort n or like n log of n and log of n. As you see it here, quicksort tends to be not that good. And where do we have this useless your bubble sort and to square? Insertion sort, we have it here. Intro sort. There are so many algorithms.
So now we did is you say the counter sort?
Yeah, counting sort. Yeah, is this counting sort? Because
The counting sort have two types, simple and stable. Isn't it?
is very look counting sort is not even in the n. Is like a big O of n. Basically, what you have a counting sort. As you can see here.
Your website you just sent us for the if you click to the counting sort, is give you two type on the top.
Counting sort, this one, right?
If you click the sort, it give you two type. Click the sort. Simple and stable.
Oh.
Which one you did right now?
The simple. I don't know what they mean with stable. Nope, that is just counting. I don't even under this is the stable. I don't know how work that one honestly. Sort simple. This is what I the one that we did it. We just have an array. We are just counting the elements, and then you are just saying like the elements, and that's it. Nothing fancier. Hey, now I just okay. Now we have one stuff. This was everything that I prepared for this class. I was expecting to use more time in merge sort or everything, but I think it was on my mistake that I didn't prevent the inconvenience with the recursion. It was completely my mistake in that case. Then we have 45 minutes that I can use it for React. I can use it for questioning LeetCode, or I can use it in the way that you need it. If you want. Because I just prepared these three algorithms for today. Just begin my.
Let's solve LeetCode problems.
Oh, if you have something specifically, I will do it.
No, like pick one and solve. I mean,
Yeah, we can take merge sort in a LeetCode maybe.
not merge.
But even if I take it, I will just copy paste what I did it. I mean, like is just say there is nothing that I will show you anything LeetCode.
Which one is a famous data structure algorithm, the recursion?
Is if I be honest, I see
During the
is
interview.
more during the interview, depending. The majority of the time will be
Try concept.
after. No. Sorting node.
What I want to
Let
say,
me.
let's practice that the most famous, most needed LeetCode problems relating to data structure algorithms.
I just
Okay.
after all the question in the LeetCode, I found the very useful is the how we call it, like when we swap it, it doesn't matter numbers or letters. For example, can you go to the LeetCode 75? It's on the top. It was on all the way on the top. No, not the number 75. It's calling the questions. Can you see the target there in the middle? Lead code 75.
Ah, yes. Okay, I'm sorry.
Can you show the text? The text on the top, like, oh no, not this one. Okay.
Which one?
Give me a second. Stack hash table. I want to
Reverse bowlens in the string
the 2
or
pointers.
reverse?
The 2 pointers. I found the 2 pointers. They're very useful to like solve a lot of like because you gonna do the swapping or whatever you want with the 2 pointer. You know, they change the
Le-
position for the. Especially, I think I did the one.
Oh, this one is good. You need to move
Here
the
the 175, 155, 151 from the.
A linked list also like popular, right?
Yeah, but we haven't checked it yet.
You don't have numbers here.
Good.
Reserve words in the string. What does it? This how it called? Array in string, the first one.
Okay.
Get out from
Okay. No, but you told me one specific number.
155. Well, 151.
151. Oh, but okay, this one. Reverse it, words in a string.
Oh no, not this one. It's too easy. Sorry.
medium
This
question.
Yeah, this is medium, but it's very easy to make. So I saw this one.
Okay, then I get.
345. Sorry, Mario.
Oh, not a problem.
That
Yes.
155. I don't know why they give the medium question, but it's really easy. You just reverse the words. So.
Okay.
345,
Yes, 345.
page 7.
Space 7. Okay, space 7. I hope I will page 7.
Did you check it?
I don't know. Page 7.
Yes,
300.
45.
45. This one, right?
Yes, this one. This is
Ah.
meant when I'm saying the swapping is a lot of question similar for the in the lead code with you which you can like solve. You just
Oh.
reverse the waffles if you can see. It doesn't matter if from the uppercase or the lowercase.
Okay, they're saying given a string S, reverse only all the vowels in the string and return it. The vowels are I, E, I0, and U, and they can appear lower and uppercase more than once. Okay, the vowels in S are I, A, E, A. Reversing the vowels becomes A, E, I. Okay.
It just reversed only waffles, not the like the other.
There are different ways that I can do it. Okay.
Did you?
Yeah.
No, sorry.
No, I didn't do it. I think, yeah.
Oh, I'm asking the other guys if you guys like already saw it, so we can move on if you didn't. Max out.
I guess the only person who tried to do this one is only you.
Okay, let me see what I could do. Okay, first one, because they are letters, their letters. I can just do something like something like a dictionary, a dictionary, and here I can have the letters. For example, just A. I will
A.
just put it one. Then A. E. E. It doesn't really matter what I am doing here. E. I. 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 O. Maybe I am just over evaluating this one. O. O. And U. What I am doing this one is, if the letter exists here, then it's a vowel, right? This one just will help me to know if what I am looking is a vowel. What else I need to do it? I can just create an array with the elements. For example, something like a cons, vowels, or letters, let's say vowels. And I will just store it here. And what I do it is just I iterate for, I will need to make it an array, right? Because an string, we cannot modify it. Then I will just say cons, letters will be equals to s dot, I think it's split, right? Split in nothing. Then I have an array. Then I have an array for letter. Then I can just say let I equals 0, I less than letters dot length. Then I can say I plus plus. Okay. Then I can say if a dictionary contains in letters in the position I, then exists, then I can say like something like a vowels dot push. What I push in this case is the letter here, right?
Mhm.
And I am just saving the letters here. Now what we do at the very end, I will basically do the same here. But if exists, if the letter exists, I will say letter in the position I will be equals to vowels dot pop, right? And I take the last letter that I have there. Oh, okay. In the pop. And then I just return letters dot join like this, right? Suppose that this has to work. In my mind, at least. I am just adding, here I am just returning. I usually sucks lately doing this. I had to verify my account.
Here,
Can someone try to do it?
with the ice cream.
Uh-huh. Let's just go here.
There
Uh,
I checked.
ah,
Working.
okay.
It's
Hmm.
work.
And
Yeah, it's working.
maybe you show us because I cannot see it.
Okay.
Can you see?
Oh, look, it's not that bad.
You are beating the 97% of runtime. The memory is 91.
Oh yeah, it was quite good.
Oh, that's cool. But since it says on a that it is supposed to be 2-pointer, I used the 2-pointer to solve.
I am using 2 pointers here.
Is it the 2-pointers?
I am just
The 2-pointer
my
only from the left to the right. I thought only this one is 2-pointer, and when you
no.
from the left to the right, you just go into the close the.
No. The 2 pointers here are 1 pointer is my dictionary or that I am looking, and this is 1 point, and the other point is what I am looking for. Then I am just checking if they exist in the 2 points. The 2 pointer is the dictionary in this case that I am using.
So actually what you did,
Technically, yes.
you just pushed the all letters from our string. And when you find out this letter again, you are just changing to the last one,
Exactly.
like vice versa. You are put like the last one A, next one was what? Next one was this one. You put
Mhm.
then this one you put here, and this one you put here. That's crazy.
Mario.
How can we start singing like you, like this, like? Because
Fast.
I really needed your brain.
It was too fast.
Yes. Look at this, it's like all N. Because we are not nesting anything. The
Yeah.
speed, like 7 milliseconds. It's 97%. You are here actually. Then when the average is here.
Yeah, it's because, but if you see it, I just try to use everything that we are just using it all the time. One dictionary, because I need to know if it's the most complicated part, I think, from this exercise is just know it if it's a, a vowel, right? And you can, I really do, okay.
This one is different solution.
Yeah, it's just different. They are just, look, they are using this one. If the vowel exists, include, it's the same. But what is the difference between include and the dictionary? Include will go and check the whole array. Yeah.
Actually,
And
like nested.
I used a lot of includes in this.
It looks like nested.
Yeah, I have 1, 2, 3 includes here.
Your is fast because you use object,
Yes.
right?
Yeah.
Um,
Here, look at that. Like inside of the for loop, you need to use again another for loop. It's
mm,
like here again, you need to look like, oh no, it's like 2n 2 square.
no, it's the same. It's big O N. It tends to be a little bit slower because it's using the include, but it's the same. It's absolutely the same because include the inconvenience when include, if we see it, is if you have an array of 100 times, this array will go wrong 100 times in this case. Oh, wait, let me see.
No, it's just C++. You
Yeah,
know,
yeah.
it's also using includes.
This is
Mhm.
oh, it was C++.
C++ is this one JavaScript.
Yeah.
This is what
It,
the weird about the lead code. This question was easy. But
Mhm.
question before I give you, it was medium, but I solved that one like 5 minutes, like the medium one, like it was 154 or whatever. Have you seen that, Maxat? That question medium one?
No, I haven't.
It's like, why this medium and this one is like a easy? This is like so.
Maybe there is kind of conditions you actually have to follow it, but you didn't follow it and you did by yourself, like how you understand it. Maybe there was kind of like this kind of complexity
Mhm.
restrictions. I don't know.
No,
Mhm.
it doesn't give me like even like do it without like
Uh,
in place or whatever.
was 135?
One,
I know is this one 5?
yeah, 151.
This one.
151. See, it's like medium question. Just
Okay.
reverse
Up
it.
this guy there. You just use reverse?
Uh, yeah. No, I did the well. Like I push it in this. I push it first in the result and then reverse at the end and join it.
No, what about the reverse function? Can we
Yeah,
use
I
it?
use the reverse. I use the reverse, but not for the like.
This one, right?
Yeah, you trim,
Yeah,
then you trim, then you split, then you reverse, right?
And then
And
join.
then you
yes,
join.
yes, that's what like I did, Mario. Just
Mhm.
here is if you can see, like I trim it, I split it,
And the reverse was just continent by a single space.
just create the new.
And yeah, but basically you just need trim, split. But when I think it's not even needed in this case, the for loop that you are using over there. Why you say the word defined as sequential character and so to separate
Because
by
see,
list.
you have the good one, you have in
Uh,
middle, you have the space. So I like clean those, like if it's empty, then like because it's in a third example, you have an empty. Like,
yeah, makes sense. Makes sense. If you have two space, one next to another one, you are just removing, right? Yeah. Oh, yeah, and you don't have any restriction with time or anything. Oh. And how was it? Yeah.
like this is the medium question. Like I give you some easy question. I don't know. It's not like easy. It's hard question.
No,
Maybe
no, no.
because we don't know the topic. That's why it looks like the heart. For example, this one looks like the heart, what the Dawood, sorry, not Dawood, the Mario solved. But if you knew it how to do it, it looks like easy. It's only because we don't have the knowledge of that particular topic.
Mm.
This one, you solve it it's because you know it how to do it, you know what's reverses. But for example, the same was I was stuck with a binary search, and that easy questions looks like very like that, not easy at all. But after when we studied the binary search, it looks like not so not so difficult.
Yes, exactly.
By the way,
Everything.
if you skip it that now what if you skip it that extra ones, how you have these ones in output? You need that space is still here.
Because he is joined and
Join
in join is the space.
But you are when you are like joining, you cannot understand which one is which one. I mean, like
No,
Why?
you can.
When you it at the beginning when you split it, you already know like which one is one. Check
when
if you
when
check
you
if you do the split from the beginning, it's no. It's three like length gonna be 3 inside of that array.
this one,
Maybe you try to solve it right now together.
Yeah, then you're gonna understand like
Yeah.
just
Okay. was okay as that. trim first, right? If I trim it, this one will disappear.
Yeah.
Mhm.
Then I will split like this, right?
Yes. And here is the answer why you think how we like join it in its split. Because you split it, now if it's like a first one, it's gonna be what? Array the sky is blue is gonna be like array of
Each
4
like
words.
you, right?
Yes. Like array of 4 words, like it's gonna be 4 words there.
Mhm.
So it's gonna be the each letter. I need to do like for each letter.
Yes.
Ah,
You need a space like in this place.
Yeah, in the space, in order to split it by the space, you know, you will have just letter and you will not know where you have to stop, I think. It will be just make it more complicated.
And when
I-
you join it, in this case, he already like join it with the space.
yeah.
And give the space inside the split.
This one is answer, right?
Yes.
Okay.
When you join it, it's gonna give you back with the like how it was in the beginning.
Oh, this like this.
Mhm. But try to add in this case that example, that a good example. I
Gonna give you extra space.
I think that is what
I already like see.
look. Those are space, and those are the one that the
Yeah,
boy
maybe
is removing.
delete this one, so right?
Yeah.
That's why I for loop it and create new array and just if it's like if it's not empty space, then push in the new array.
Can we avoid to create a new array? How to delete it? Like, for example, if you do for let I equals to 0,
Using
yes,
slice.
length and I plus plus, and if new s I is equals to like this,
Give it the space in there. Yeah.
then new s splice, right? To delete
That yeah, but that is giving you a problem
and like
because you are mutating the element. Oh, makes sense. Possible? Yeah.
I just
Yeah.
have it.
It was a splice or slice?
Delete one.
It's
Splice.
splice. Yeah.
Start,
May,
start is that. It's index number. Okay, I understand. So
Gonna be
I delete one,
I guess.
delete count 1, and this one is additional. We don't need, right?
I guess yeah, it was. So log. Oh, you cannot cancel log it to check it. So.
Okay, then this one done,
So,
and I do what?
new s dot reverse dot join.
Yeah, return. New s dot reverse dot join like this, right?
With the space.
Mhm.
Oh, space. Do you have yeah, I need space. Yeah, I need space.
The last one doesn't work.
Yeah, I think like a uh,
Oh, sorry. Array.i new s.i is
mhm.
if it's empty, then like this maybe.
Mhm.
And maybe delete that space inside. Just try it without.
One is deleting.
No, delete the space inside the break. Like, what is it? Like,
Let me see. Yeah, possible is
Yeah, yeah.
okay. Try to submit it. Let's see what you want. Ah, very good.
second.
Yeah, around time is good. But memory,
Though it's fine.
mm,
I
Uh,
don't see I don't see much inconvenience on it.
Still.
And yours, debut? How was it?
this was my first medium question which I solved.
Check it out. It's more like this medium question. They are easy, so we can.
No, not all.
I mean, more. I said not all. I said more.
We have a follow-up question. If the string data type is mutable in your language, can you solve it in place with all one extra space?
Oh. Oh.
Here we go. In place with all one. So it means you cannot use for loop automatically.
No, you can once, no?
Place.
It
In
has to.
It's like you cannot create the like a new like you cannot like create the new variable for the
That type is mutable in your language. Can
No,
you
you can use an extra variable. I mean, you can all.
here we are
Yeah.
creating
not return the new one.
And there is another thing. JavaScript, you had to create an array. You must create an array for one reason.
Mm.
Because the strings are not mutables in JavaScript. You cannot do anything.
Tell
Let
them,
me-
call them, Mario.
Huh?
Call them, say them like who.
No. You cannot use it because strings are not mutable in JavaScript. That is one inconvenience.
O1. I want to find O1.
I see like you can use the language. JavaScript. Okay. Yeah, JavaScript.
So anyway, you have to create a array, right?
Look in one line solution. That was funny.
This one.
Yeah, it's just interesting.
Two on. Since it's impossible.
Uh-huh.
Okay, you're right. You see. I guess this
H.
O1 is like for different languages, not the JavaScript
Yeah, I think in C you can do it.
or something like this.
Mhm.
Okay. I like
Look,
single
they use in a regular expression. Okay, I'm very bad with it.
Which one? This one?
Yeah. Look, there is something split, and there is one regular expression in the middle.
I don't know what it.
Yeah, I
Look
don't
at
know.
it. It's beautiful.
No, it's a full.
Like a lot of things like we did. What is it like? I don't
This
know
one?
yeah, how to load it. Like.
It looks like the emoji for me, like the
Yeah,
person.
same.
I'm sorry.
Just
I don't
random
know.
signs, like just random signs, and it means something. It's supposed to mean something.
Yes, called regular expression. I don't. I every time that I need to use it, I Google. I don't know.
No one knows this.
There are people. There are people. There are.
Perfect solution, JavaScript. Oh, look at this.
Uh-huh.
JavaScript. Oh, it's, yeah, they're using while.
Yeah.
Same, right? Like the follow.
Yeah. The same, just iteration. And then, yeah, that is the thing. They are using the stream by stream. I am not sure if it is.
Oh my god. Oh,
Because they are not using that extra space that we are using. That one that you are seeing over there is just the reverse and join.
Spaces. No, it's OOM still. Yeah, I'm using extra cons.
You cannot do it less. I mean, like,
Okay. Never mind. Thank you.
you can make it even more complicated. Okay, then thinking about what we will do next week. Eh, mm, okay,
Uh,
yes,
Mario, so we are like
yes.
learning the main data structures, but
Mhm.
to be honest, we are not practicing them. Like we are learning, but not practicing. Maybe do you have some kind of like a list of the questions, like for each, like for recursion, the for Windows slide, for like
Okay.
the list of the questions we can the practice by ourselves. Maybe it's kind of maybe it might be the homework, for example.
Okay. Then let me just during the week I will put you the list. At least that the one that we see it. At least for the first two, three that we saw it, and that I think it will make more sense. I think like it's a very good suggestion that you are telling me. The the idea or the suppose it is that the same question that we have it here in this thing that is not loading to me. Okay.
Yeah, we have it there, but it's only like the one question for each of them.
Yeah, you are right.
For
Okay.
example, the last week we learned about the recursion, and today I already forgot it. Since like
Okay.
I need more practice. So I
Oh,
guess the guys also need.
yeah.
okay.
All
Okay.
I understand in that lead code 75, uh, since we used the two pointers in the sliding window, that's why I'm here still.
Okay, then I will prepare 3, 4 exercises of each, and I will be sending to you into the Slack channel, maybe Monday or Tuesday, because
Well,
I don't have it, and I have to look at that they are not that complicated, at least that they are solvable.
I was trying to search by myself, like
Uh,
internet, and it's not. It's not. I was thinking maybe it's just like the one of the data structures what we learned it, but when I'm trying to solve it, I understand it and then that it's not the same. It could be like totally different data structure, maybe which we didn't learn it yet. So that's why it would be much better if you provide it for us instead of we are searching by ourselves,
it make totally sense. Yeah,
sliding
I can.
pointers like them, the many one them.
Okay, then what we will do is, since I will send you a couple during the week, and for the next class that we are just using searching, that this is the topic, we will go over the topic, and at the very end, I will give you 2, 3 exercise just to leave it. And I think that makes sense. I have been not doing it. Yep.
Yeah, thank you.
No, thanks to you because I think like your feedback is the most important. Then for today, if we have question or anything, we continue. If not, I wish you. By the way, next week my class will be Wednesday because I will change with Marat for Friday because I need to do something on Friday. Then in order to not to have inconvenient, it will be the class with me on Wednesday. Okay, just that I was talking for them. I need to go out of next Friday and then I already talked to them for that. Then this class will be on Wednesday, and Marat will be with you on Friday. Marat
Right.
is you on Wednesday, right?
Practice on
Also
And Thursday.
Thursday. Then it will be Thursday that I will be here.
Oh, instead of Marat, and the Marat will be on Friday.
Yes. Mhm.
Sounds good.
Okay, yeah. Then I wish you a good weekend, and if I have something, I will share with you during
So much.
Monday or Tuesday. Okay, bye bye. See you soon.